In this video, we're going to be learning about if statements and operators. We're going to be graduating on now from using TextEdit as our text editing application for when we write our programs and code. So we'll move on to using something a bit more common that's used by a lot of programmers in the industry, and just in general, this is a pretty popular application. There's a specific term for these kinds of text editing applications that are designed specifically for programmers. They're called integrated development environments. So you might hear them being called IDE. Basically, they're just special text editors for programmers. So they come with a lot of built-in features that would be useful for programming. So things like generally most of them come with some sort of built-in terminal, and also you might have like auto completions for specific languages that you want to code in, or these things called LSPs, which stands for language server providers. No, language server protocols. But yeah, basically these things help you autocomplete essentially some of the code you're writing. So I wanted to introduce this a little later, this IDE that we're going to be using called Visual Studio Code, just because I wanted to get you guys familiar with writing code in a simple text editor, just so that you guys have an understanding that all you're doing when you're making programs is you're editing text. So I didn't want these sort of tools to sort of get in the way of this idea that all you're doing is editing text. So if you haven't seen it before, the program looks like this. It's called Visual Studio Code. If you don't have it downloaded, you could just go to your browser and type in Visual Studio Code. It's made by Microsoft, so yeah, just download it for your platform. I'll give you sort of a quick demo of at least some of the common sort of things that I use in Visual Studio Code. I normally only use about 4 commands, or just a few commands, sort of shortcut commands inside Vscode. One of them is Command J. So what Command J does is it lets you open and close the terminal. So if I go Command J, I have a terminal right here. So you can you can adjust how high the terminal is just by doing that. So if you go Command J, you can open it and close the terminal. So Command J lets you toggle the terminal. You can also, if you look up here, there'll be a terminal button or icon, so you can also open up a new terminal like that. And another command, pretty common for most applications, is just a save command or save file. So Command S. So notice how in this notes.txt file, if you look at the tab in the right corner here, there's a dot. So the dot means that the current file is not saved at the moment. So you can just go Command S and the dot will go away and become like a cross like that. So if I make another edit to the file, then the new edit, the file will be changed. So the new version of the file won't be saved. So if I add a space here, it becomes a dot again. So I can save it again, Command S. Another command that I normally use is Command P. What this does is it opens the command palette. I don't know how you spell palette, but so the command palette inside Visual Studio Code. It lets you jump around between your files pretty easily that are inside your current workspace. So we'll talk about workspaces a bit later, but actually I'll just show you right now. So on the left here, you'll see this sort of icon here. You can open, you can sort of drag that out. So this here is, I'm pretty sure it's called your workspace. So basically you can add folders here. So usually with larger programs or like software that you're building, you're going to be working with multiple files in a single folder. So what you're going to do is you're just going to essentially have the folder here. So you can go ahead and go to the file section and you can add a folder to workspace, or you can just open up the folder directly in your terminal if you were to use the code command. So for instance, right now I'm in the if statements and operators directory. I can go code, and then if I type dot, which represents the current directory, and then enter, notice how I've opened up the entire directory inside the workspace. So now instead of just having a single notes.txt, the notes.txt is inside the directory that's inside the workspace. So I can just open that. So if I were to add multiple files, so file 1, file 2, file 3. So now I've got 3 files in the directory, the if statements and operators directory. If I go code dot, then I'll have all the files inside the directory that's inside the workspace. So with Command P, I can jump around between the files. Command P for the command palette. So if we go Command P and I start typing and I type F, then I'll have access to file 2 here and file 3. So you can jump around pretty easily. So if I go Command P again, and I type file, and then I go file 3, then it will open them up as tabs. So each file will have its own tab. Another command that I use, I'm pretty sure this is quite a common command for all applications on Mac OS. If you were to type command and then followed by a comma, this should open up settings. This should open up the settings for any app. So if you go Command P, then this will be the settings for Vscode. So you can do a lot in the settings. Vscode is highly customizable to whatever you sort of like. So just at the top here, you can see that we can change the font size if we want. I'll make the font size a little bigger for the video. So I'll make it 26 pixels. And I'll just keep it like that. So if I go back here, you should see that it should be a bit clearer. So these are all the commands that I usually use inside VS Code. These commands are pretty useful. You don't have to use them, but I keep it pretty simple so I don't have to remember too many things. So I'm just going to go back and open up a terminal, and I'm going to remove file 2 and file 3, and then list to see that they're gone. So any changes you make inside the terminal obviously will be reflected here inside VS Code. You can also split the screen in VS Code. So if you have a look at the sort of top right, there'll be a little icon where you can split the screen in the middle. So if you click on it, you see how it basically opens up the same file but another copy of it. So you can do that. just gonna rearrange a few things. I'm gonna rename the notes to command, and then I'm gonna open that up. And then I'll just add another notes. So let's talk about logic. Logic describes the way we make decisions based on true or false values. We use logic every day in order to make decisions about how we want to act in the world around us. So for instance, you might have asked yourself a question before, something like, is the taco store open today? Yes or no? Notice how, so if the taco store is open today, then yes, I'm going to eat tacos. But if the taco store isn't open today, then I guess I'm going to eat something else. I'm going to eat noodles. So notice how depending on whether or not the taco store is open or isn't, you can only pick one outcome, because the taco store cannot be open and closed at the same time. Like, it doesn't make sense for something to both be open and closed at the same time. So based on whatever information you have to decide between two outcomes. If we were to just tweak this question slightly, and instead of it being a question, is the taco store open today? If we tweaked it slightly and changed it into a statement, so how would we change this into a statement? Well, we could say, the taco store is open. So this would be a statement. So if we had a statement like this, then all of a sudden, I mean, we could say yes or no, but we could also think of it as false, or not true and false. So just by tweaking the question into a statement, instead of using yes and no, we could also think of it as true and false. So same thing, if the taco store is open, true, let's eat tacos. False, let's eat something else, noodles. This distinction between yes and no and true and false is really just a semantic difference. The important idea to understand is that your computer, just like yourself, makes decisions based on two possible states. In other words, a computer only understands binary. You might be familiar with binary. So usually people, when they hear binary, they think of zeros and ones, which is true. However, these symbols that we use, zeros and ones, are merely just symbols that we use to represent pairs of outcomes. The important idea is that binary is about choices between two possible states. So far in the course, we've written programs where the instructions have executed sequentially, so line by line, one after each other in order. We can make programs more useful by using logic to control when and when not an instruction should be executed. So in other words, we can use logic to conditionally execute instructions. Or again, in other words, we can use logic to control when and when not to execute instructions. This is done using if statements. So the basic pattern or syntax for an if statement in C is going to follow this. So it will be if, an if keyword, followed by an open bracket, close bracket, and then some condition in the middle. And then you're going to have an open curly brace, close curly brace, and then your instructions will be in between the if statement. So if the condition that's in between the open bracket and close bracket, if this condition is true, then this instruction will execute. If the condition is false, then the instruction gets skipped and the program continues on. I'm just going to add line numbers to the side. So if we had a full C program, let's do hash include standard input output.h, do it in main. So if we had an actual C program like this, so your program is going to start at the top, and then it's going to go to the next line, then the next line, then the next line. Well, I mean, your program is actually going to start inside the main function, but you get the point. So once your program reaches line 6 on your if statement, it's going to see the if keyword, and then when it sees the if keyword, it's going to look for all the characters in between that come after the open bracket and come before the closing bracket, and this is going to be the condition. So it's going to evaluate the if statement is going to evaluate this condition, and if the condition is false, or let's say if the condition is true, then the computer will go and execute 7, 8, 9, and then continue. But if the condition is false, then the computer will essentially skip to line 10 and continue going. So basically the computer skips to this character. So it skips all the instructions that come before this character and come after the open curly brace. So what does it mean for a condition to be true or false? And how do we represent conditions? So what does it mean for a condition to be true or false? And how do we represent conditions? So in C and a lot of other programming contexts, true, or at least the notion of true is represented Or actually, we should probably start with false. False is represented with the number 0, and true is represented with 1. More accurately, false is always 0. And since false is always 0, and true is the opposite of false, then true is represented with any number that is not 0. So true is represented with any non-zero number. Let's make another C programming example. I'm going to make a file, and I'm going to open it up straight in Vscode. So the command is going to be code, and I'm just going to make a source.c. And you see how it opens up directly in Vscode. So we'll do our includes, and then in main, we'll add our return statement. So basically, if you have a 0 here, that means that the if statement is going to evaluate this 0 to false. So whatever instruction that you have here, if you put a 0 in between the if statement, then the if statement is going to skip from line 6 to line 10. And it's going to skip your instructions. But if you have a non-zero number, so let's say you have like a 10, then your instructions, since 10 is a non-zero number, this is going to evaluate to true. And if true, then your instructions will execute. You can also have a negative number. So if you put 1, 2, 3, then since minus 1, 2, 3 is still a non-zero number, then this if statement evaluates to true, and your instructions will still be executed. You can actually just quickly sort of compile a file. We'll say we'll put an if statement here. I think we can get rid of this command now, the command file now. So if you add an if statement here, saying inside if, now true is, you can't actually have the word true there. So if we write, let's say, a non-zero number like 13, let's save our file. We'll open up our terminal with Command J, and then I'm just going to compile our source file, clang source.c-o source, enter. So we've made a mistake. We didn't end our instruction with a semicolon. Command S to save, Command J to open terminal. Just clear the screen. I'll go use the arrow up command. I'll use the arrow up to go back up to a previous command. Recompile. If we run source, we'll see that our if statement did execute, or our instructions inside the if statement were executed. So if we do a 0 here, then we should expect nothing happens, which is what we should expect. So basically, we use numbers to represent conditions, but I suppose more accurately, we use expressions to represent conditions. So an expression is any combination of, let's say, values, operators, and yeah, I think that's about it. Basically, for instance, if I go back to source, and instead of having just a value or like a number here, I can do some arithmetic using the plus operator. So if I do like 3 plus 3 plus 6 and then minus 12, then 3 plus 3 plus 6 is 12, 12 minus 12 is 0. So we should expect that if we compile this and then run source, then nothing happens, which makes sense since this evaluates to 0. So what you would, I suppose, call this entire thing, this entire sort of arithmetic sequence, you would say that this is an expression. So you guys would have already probably written a few expressions before, in the sense that maybe in previous videos or your modules, you would have done something where you made some variable and then you assigned the variable with an expression, or so like that. So 5 plus 10 is an expression. Or you don't even need to really do that. Like, oh yeah, I figured it out. Sorry, an expression is any combination of variables, values, and operators. So an expression would also, this would also be a valid expression. So if you had, let's say, int number, if you just wrote number here on line 8, that's also, this would, just by itself, this would be an expression. So yeah, I mean, if you had a number equal to 0, we can do number equal to 5. If you put number here, so if we had it like this, then we should expect that our if statement does execute, or our printf does execute. If we recompile and then run that, we're inside the if statement. So our printf did execute, since number is true, because number is 5 and any non-zero number is true. So yeah, so basically an expression can go here. Basically an expression is an expression condition, same thing. So let's go back to our notes. So an expression is any combination of variables, values, and operators that combine to produce a value. So what is an operator? An operator refers to a symbol used to perform an action on one or more values to produce a result. So you guys are already familiar with the arithmetic operators, which is the plus symbol for addition, the minus for subtraction, the asterisk for multiplication, and this one for division. So you guys already know how to use the arithmetic operators to do arithmetic and produce new values. So like if you did stuff like that, you guys know how to do that. Now we're gonna talk more in this video about comparison operators. So comparison operators are pretty important. A comparison operator, basically like the arithmetic operators, where you have two values, a comparison operator will compare those two values that you have. So let's say you have, an A and a B. A comparison operator will compare A and B, and depending on whether or not the expression is true, the comparison operator will either produce a 1, which represents true, or it will produce a 0, which represents false. The most important one is the equality operator. So this is the symbols for it to perform an equality operation is a double equal sign. So it's very important that you remember and understand the difference between using a double equal sign and a single equal sign, because a single equal sign, if you guys remember from the previous video, if you do something like int a and then you go a equal to 5, a single equal sign in generally most, if not all, programming context, a single equal sign means assignment. So what we're doing here is we're making a variable a, and then on the next line, we're assigning the variable a with the value 5. So just remember the difference between equality and assignment. Equality is double equal sign. So for instance, if we go back to source.c, so we have our a little source file here. What we can do is, okay, we already have our variable called number, and we know that number is 5. So if we write, let's say we perform an equality operation here. So if we say number and then equal to 5, so what happens here, once the program gets to line 8 and sees the if keyword, it will look in between its brackets and then essentially evaluate this expression. So since the value inside number, so it's going to go and get the value inside number, which is 5, and since 5 is equal to 5, this equality expression will essentially collapse or evaluate again to produce 1. And since 1 is true, then this instruction will print. So we can try that out like this. We compile and then we run source. you can see that our if our print statement printed our message. So if we change this to 4, so now the number inside our variable number is 4. We should expect that nothing will be printed since number is not equal to 5, and this will evaluate to 0. Then this gets skipped and the program continues on and ends. So we can compile this and run it. Right. Why is our program printing an if statement? Maybe we didn't compile correctly. So we'll recompile and then we'll run our, okay, so it's just we didn't compile it. So yeah, so that's the equality operator. If we go back to notes, so another operator is the less than, which is this symbol. So if you think back to your sort of maths in high school, this is the less than symbol, and then the other comparison operators are the greater than. You can also do less than equal to, and then you can do greater than equal to. And also another very important one is the not equal to. So this is with an exclamation mark and then an equal sign. So we can do a few examples. So if we do this, what do you think will happen? If your answer is that our print statement prints, then you're correct. We can check that quickly. So our statement prints. If we change it to number greater than 5, then we should expect that since 4 is not greater than 5, so 4 greater than 5 is going to evaluate to 0, since 4 is not greater than 5, and then our statement will be skipped. So we can try that out. So nothing printed as expected. Basically I can show you all the prints like this. We'll have we'll do int a equal to that, and we'll do b. So we'll use these numbers. So we have int a equal to 5 and int b equal to 10. So we'll go a less than b. Sorry, we'll make 5 less than 10. equal to %d, and then we're gonna feed it an expression, and the expression is gonna be some combination of variables and an operator. So we can do that. We'll do 5 greater than. So we're just doing this to see what our things print. 5 equal equal. So this is the equality. We want to check the equality. We can also do less than equal. Now this time I'll just change it to 5. So if that's the case, we'll do A, since A is 5. Oh, you know what? We'll just hard code the values. Then we could do greater than or equal to. Right, 5 greater than or equal to 10. And then we'll say if 10 is not equal to 10, so we'll do 10 is not equal to 10. So don't forget that we need to write our semicolons at the end of each instruction. Hopefully that all makes sense. I'm just, in each print, I'm just printing the value of our expression that's using a comparison operator. And that value is going to print in this position where this format specifier is. And we can compile the clang source.c -o source. Clear the screen and run it. Okay, so 5 less than 10. 5 is less than 10, which means that the operator is going to produce a 1. 5 greater than 10. 5 is not greater than 10. So this statement is false. So the operator produces a 0. 5 is equal to 10. This statement is false. So the operator produces a 0. 5 less than or equal to 5. 5 is not less than 5, but 5 is equal to 5. So this statement is true. And then we have 5 greater than or equal to 5. This statement is false. 5 greater than or equal to 10. This statement is false. And our last one, 10 does not equal 10. 10 is equal to 10. So this statement is false. So we get a 0. And then these zeros are, we can use these 1s and 0s inside if statements to conditionally execute other instructions. Okay, so let's actually make a program now. I'm gonna remove our source.c source file and also remove the source executable. So if I list that, we just have our notes. Let's make a new source file. We'll call it is5.c. So we'll make a program that prints if the number that is given by a user is 5. So we'll do our includes #include stdio.h, then int main function, and we can return 0. So we want a program that accepts user input, accepts a number from the user, and if that number is 5 then print a message. By the way, if you guys ever see me use these double forward slashes, so what this is a comment, meaning that essentially the computer, anything that has 2 forward slashes in front of it, any text, the computer will ignore the entire line. So I'm pretty sure maybe you can also do like, yeah, so you could do multi-line comments as well if you use a forward slash and an asterisk to start it off, and then an asterisk and a forward slash to end it. So all of this basically, yeah. Okay, so let's write our program. So we're going to take user input. So we're going to scanf some input. We're going to scan a value that we're going to store in an integer variable. So we'll use %d, and since we're storing a value inside a variable, we're going to need an integer variable. So we'll say it's int, we'll call it input, and then we'll give scanf the address or location of input. Don't forget to add our semicolons. Before we print, maybe we should add a nice message when the program starts so that the user knows what to do. So we can say enter a number. So now once the program gets to line 13, then we will have some input from the user that's stored inside our input variable. So remember that scanf is gonna wait until the user inputs something. Now we can use an if statement to check if the number that was given is equal to 5. So if input equal 5, then we can do something. So we'll write our instructions in here. So these instructions will be executed. So we can do it like this. Write printf, the number is equal to 5. So if the number is in fact equal to 5, this will evaluate 1, and since 1 is true, then our print will print. Now I'll probably just do it like this. Hopefully that makes sense. Let's compile. Okay, so plain is _5.c -o, and then is 5. We'll call our executable. Enter. You can see that we have our executable here. Let's run it. Is 5. Enter a number. Probably should have added a semicolon or some spacing there, but that's fine. So if I enter 100, nothing happens. So maybe for our program, we should add a message so that the user knows nothing happened. But our program did behave as expected, since input was 100 and 100 equal to 5 is false, then this message is skipped and then the program ends and nothing happens. So what we can do is maybe if the program gets to line 17, we could say that the number is not equal to 5. Now, if we do this, what we can do is we can use double return statements. So you might not have seen this before, but you can have multiple return statements inside inside a program. So we can put a return statement right here. So what's going to happen is this return statement, this return 0 on line 16, will only ever be executed or will only be accessed if this statement is true. The reason why we would put a return statement here is because if we didn't have the return statement to prematurely end the program, that means that after we finish printing our print statement on line 15, the program is still going to continue on to line 18 and print line 18. So it doesn't make sense for us to print both print statements if the value is in fact equal to 5. No, I'm not wrong. So if we just had this and we compiled, if we put 100 again, the number is not equal to 5. But if we put 5, then the program is gonna print both statements. The number is equal to 5 and the number is not equal to 5. So if we do get a value 5, I'm just gonna add a few new lines. Do that. So if we do get a 5, we don't want our program to continue on to line 17. We only want to print one print statement. So if we don't want our program to go to line 17, then we can end our program right there prematurely. And if we do this, the program will never hit line 18 because it just ends at 16. Clearly, if input is not equal to 5, then the if statement gets skipped anyway, and then we have one print statement. So if we recompile, and then run. So if we enter 5 again, we should only expect one print. Now you can do it like this, but the reality is you won't do it like this. The reason that I wanted to just introduce this pattern of these double return statements is just to sort of give a preface to why you would use this following pattern. So if let's say you only wanted to execute one print statement, so you only either want to execute this or you only either want to execute this, then what we can do is we could use an else clause, and then we have the curly braces as well. So with this else keyword, you always have to use an else keyword with an if. So you can't just have an else by itself. It has to be used in conjunction with an if. And clearly else just means that if the expression or condition inside the if statement is not true, then else will be executed. So all the code here will be ran instead, which means that we don't need to worry about this sort of return, like returning prematurely, and we can just add our other print statement inside this else clause. So we can sort of run through it manually. So if the number, when we run our program, if we give a number, and let's say that the number we give is 5, we give the number here, so the number will be 5, not really, but the number here will be 5, and then since 5 is equal to 5, the equality operator will produce 1, and since 1 is true, our if statement will execute, this instruction will execute, and since this entire instruction executed, this else statement will be skipped. So only either one of these can execute. You can never have both an if and its corresponding else execute. So if the number we gave was 100, then this statement will be false, and if this if statement is false, then our else condition, which is just the opposite of this, will execute. Not sure if I don't remember if we already compiled it. Oh, sorry. We put equal to 5. Instead of an equality, we can check if the number is less than 5, so we can try that. So what I'm going to do this time is I'm going to recompile our is5.c source file to produce a different executable, and I'm going to call that executable less underscore 5, and then let's just remove the is5. If we run less 5, if we give 10, the number is not equal to 5. So we should change our messages. Number is less than 5 is so let's recompile. Run less 5. 10, the number is not less than 5. Let's run it again. Let's give it minus 23. The number is greater than 5. So what do we have that's wrong here? Minus 23 is not greater than 5. Minus 23 should be less than 5. So we can sort of figure this out and see what's wrong. So if we read both of these statements, the number is greater than 5 and the number is not less than 5. Both of these statements mean the same thing, because if a number is not less than 5, it means that the number is greater than 5, or at least the number could be equal to 5 as well, but So our messages are wrong. So if we're in this on line 15, if the computer somehow gets to line 15, that means that this condition is true. So the number is less than 5. And then the opposite, this else statement is correct. But that's just for clarity, we'll say greater. So the number is greater than 5. So we can recompile. Do that again. Minus 23. The number is less than 5. That's correct. Let's do a bigger number. The number is greater than 5. So that's sort of how you could use comparison operators to make an expression, and then you can use the expression inside an if statement to conditionally execute instructions. So we can use logic to decide when and when not to execute instructions, or in other words, we can control the flow of execution. So if you consider sort of execution in a sort of linear sense where the computer starts from the top and goes down, then the computer will go down, and then the flow of execution, once it gets to line 14, it will essentially branch off between two sort of outcomes. So it will branch off between two outcomes depending on the expression. So one outcome that it will branch off to will be this, and another outcome will be this. Okay, let's move on and make another program. So we'll just get rid of this, open up the terminal. Let's make a simple calculator program. I'm going to call it calc.c. So let's define some behavior for our program. When we run our program, calc, so this is going to be a simple calculator. Let's only work with the simple arithmetic operations. So we'll handle addition, subtraction, multiplication, and division. So these are the only 4 operations that we're going to do for our simple calculator program. When we run our program, we're gonna ask the user which operation they want to perform. So basically they can only perform one of these operations, and to keep it simple, they can only do the operation with 2 values. So when we start our program, let's tell the user the options. So we have addition. Now we're going to map each operation to a number, so that way it will be easy when the user tells us what they want. So we can map add to 1, sub for subtract, and then on a new line we can keep multi, have that as 3, and then division we can have as 4. We'll have another message below this line telling the user we'll say which operation, and then the user can enter a number here. So they can enter 1 if they want to do add, 2 if they want to do subtract, 4 if they want to do division. Then we'll have another message, enter 2 numbers. Then the user can enter number A and B, and once they hit enter, they should get something like, so since they're performing addition, because we've defined 2, they're performing subtraction, because we've defined 2 to be subtraction, then we'll print out a message saying a minus b equal to result. So the result will be what we calculate. So let's write this all. Let's keep this all inside a comment in our program, so we can have it. We can view it while we write our program. Do a hash include up here. Standard input output.h. And we'll do int main. Add a return statement. Okay. So there's going to be a few print statements. So let's do the first two. Or we can do the first three. Do all at once. But before we do that, I'd like to define some variables first. Since we already know that we're going to be scanning 3 variables. The first variable is going to represent the operation that the user wants to do. And then the other 2 variables are the values that the user wants. So the operands. So the operation, we could store that inside an int. We could say int input. So this variable can be an integer, since we're only concerned with numbers 1 to 4. But I think for the values here that the user gives us, I think it would be better to use floats. So that way it'd be easier for us to format the division operation rather than having to make separate variables. Like rather than having to have division in its own float and then the other 3 inside integers, we could just define all of a and b to be floats, and then we can just format the results as either whole numbers or decimals. Do float a, b. We have our print statements. This first one's going to be this. The second one's going to be this. Go to add 1. And then subtract will be 2. So on a new line, we'll have multi as 3. And then we'll have division as 4. And then we can have a new line. So then on the next line, which operation, we're going to print another message. So we'll have print, what was the message? Which operation? Which operation? Question mark, space. I'm going to put the input after this space. We can go scanf. The first input is going to represent our input variable. So it will be %e in the address of input. So we'll print another message. This time it's going to be enter 2 numbers, a and b. So enter 2 numbers. And we'll have another scanf. Now, a and b are going to be floats. So we'll use %f. And then we'll put that in the address of a. And then b is in, this one is in the address of b. And then the next thing is we print the calculation. So now we can do printf. Well, first we have to determine which operation we're doing. So we need So if the user gives us 1, then we need to only print the addition operation. Let's use an if statement. Now, if input is equal to 1, that means we're going to perform addition. So we can do the same thing for the other operations. If input is equal to 2, then we're going to perform subtraction. If input is equal to 3, then we're going to perform multiplication. If input is equal to 4, then we'll perform division. So this is sort of how we can handle the logic depending on what input is. So if input is any one of these numbers, so if input, let's say if input is 3, that means the other 3 if statements will not execute. If input is 2, that means 1 and 3 and 4 won't execute. So only one of these if statements can ever be executed, because input cannot be 2 numbers at once. Input can only be 1 value. We'll add our prints in here. So it will be A, and then followed by the operation, and then B, and then equals space the result. So A is a float, so we're going to have a %f here, and then B is also a float, so we'll have a %f operation, and then the result, depending on what operation we're given. Actually, we could just print it as a float. It doesn't really matter. So we can take this, and between our print statements, say %f. We could do, so number 1 represents addition. So we're going to have a plus C, %f. Now since A and B are floats, but we're performing addition, and we can we could do that, so we can just leave it like this. Let's just say we want 2 decimal places for all our values. So we're going to have to give 3 arguments to printf, 1 for each format specifier. The first one is A, second one is B, and then the last one is going to be the calculation. So A plus B. So that's basically our logic, or that's our print. So I'll add that there. And then I'll just tweak each of them. So 2 is going to represent minus. So if we're inside this control block, that means we're performing a minus operation. 3 represents multiplication. So if we're in this control block, we're doing multiplication. And this one is division. Okay. So hopefully all that makes sense. Let's see if it works. I'll save it, go back here, and claim calc.c -o calc. Alright, that's a good sign. Let's run calc. Add subtract, multiply, and divide. So let's perform a multiplication. We'll do 15.31 and then we'll do 18.04. That looks kind of right. I'm not too sure what the numbers are, but I mean, it's probably right. So we can add a new line to each of our responses. So that way it just looks a little cleaner. That's to division, so we're going to do 4, enter two numbers, and 1, and we'll do 304.34, and there we go. So that's how you make a simple calculator program.